So since you're in the data science track, it might be a good idea to figure out what is data. And so for a definition of data, we're going to go to the number one source of all information, Wikipedia, and we're going to get the definition: data are values of qualitative or quantitative variables belonging to a set of items. So the first thing that you can see from this definition is that you need a set of items to be measuring things on. And so the set of items is sometimes called the population in statistical inference. It's basically what you're trying to discover something about. So it might be the set of all websites, or it might be the set of all people coming to websites, or it might be the set of all people getting a particular drug. But in general, it's a set of things that you're going to make measurements on. Variables are measurements or characteristics of an item. So they might be measurements as in you measure the height of a person, or you measure the amount of time a person stays at a website, or they might be more qualitative characteristics. So it might be the places that the person looks on the website, or whether that you think the person visiting is a man or a woman. And so you have both qualitative and quantitative variables. So qualitative variables are things like country of origin, sex, or treatment. They're not necessarily ordered, and they're not necessarily measurements in that way. Quantitative measurements, on the other hand, are usually measured on a continuous scale. They're things like height, weight, and blood pressure, and they usually have an ordering on that scale. So what do data look like? So you might think in your mind when I say data, something like a big Excel table or something like that, but actually most data actually starts off in a very raw form. So this is an example of a FASTQ file, which is a type of file that's produced by a next generation sequencing machine. So a typical experiment will produce hundreds of millions of lines of text files that look like this. And so you can actually see here in this file, you can actually see a sequence here of a particular read that comes from a person's genome. And so what you want to be able to do is parse that file and collect those data and maybe infer something about their genome. Another way that data might look is an API. So this is actually a picture of the Twitter API website. And so what you might do is you might try to get a particular URL. So you might try to access that URL and get information from it. And what you get back is something like this, which is a structured form of data that isn't necessarily something you would see in an Excel file, but is a structured form of data that you might get back. Here's an example of a medical record. So this is, again, another form of data. People are very interested in studying medical records and trying to understand how people can either improve the way that we insure people or improve the way that we give people medical care. And so these data, again, are text files that are not necessarily formatted in a very nice way. And so what you might want to be able to do is do things like extract the allergy name from this text file, or subtract or extract when different things were ordered and so forth, and then use that data to maybe answer some questions. Data might also be a video. So in this particular case, machine learning experts developed an algorithm that could learn whether a video was a cat or a video of something else. It seems like kind of a trivial application. It's actually quite a hard problem that they solved. But in this particular case, the data were actually the videos themselves, or stills from the video themselves. Data might also be an audio file. So this was an example of Darwin Tunes, where people actually studied the evolution of music over time, where people decided whether innovations introduced into the audio file were interesting or not. And so over time, they evolved music that was more melodious and more interesting for people to listen to. So the data itself was actually the audio files in this study. Data might also look like access to files, whether through an API or through spreadsheets, through open government websites. So for example, data.gov has a lot of data sets that might be accessible, and those data sets might be in any number of formats, from very simple tab or comma separated files to Excel files to something that's much more complicated and messy, like raw text files. Rarely do data look exactly like what you'd expect it to see at the beginning of a data science project. So here's a very clear, easy data set where you've got variables in columns and observations in rows, and it seems like it's very easy to analyze. It's very rare that the data come that easily processed before the beginning of a study. So the data are actually the second most important thing in data science. The most important thing in data science is actually the question you're trying to answer. And so the data should follow that question. It's the second most important thing to the question. Often the data will limit or enable the questions you're trying to ask. So in other words, you start with a question and you might not have the data to be able to answer that question. So you have to modify the question to be able to answer sort of a sub-question or a related question. But having data in general can't save you if you don't have a question that you're asking. And this is sort of the key take-home message, maybe the theme of this data scientist toolbox is focusing on having a question that you want to answer with your data and not being driven by the fact that you have data.